Students, this video class is about the module 3 of the structural dynamics topic. So in this module 3 of the structural dynamics, here you can see we need to study about multi-degree freedom systems, then about the shear building frames, how it is based on that. Then we have to generate the equation of motion, that is, we know that mx double dot plus kx is equal to 0, or mx double dot plus cx dot plus kx is equal to 0. We are having different equations out there. So that we studied in the case of a SDOF system. So now we are going to study about the MDOF system, that is multi-degree freedom systems, and how to find the frequency, how to find out the mode shape. Mode shape we will be studying about that. That all things we need to study in the third module. And the third module we will be mainly studying the free vibration of a MDOF system, and the fourth module we will be studying about the forced vibration. Okay, that is it. So same as that we have covered in the first and second module, the theme will be the same. That is, we will be having the free vibration in the SDOF in the first module. Then we studied about load, different types of load, and find out the response, etc. Similarly, we will be studying here also. Now, coming into this third module, so some of the classes were taken. We have taken some class was taken in the offline mode also. But anyway, I am just going through the topics which we covered in that class also. Here you can see what is an MDOF system. That is, if I am having more than 1 degrees of freedom, it is known as a MDOF system. So what is degree of freedom? Degree of freedom means the possible movements. For example, if I am having a system like a arrangement like this, one mass is a single beam and column is there, then another thing, I am having 2 stories. That is, I am having M1 and M2. Then I am having like this 2 story. So this is a SDOF system. This is a MDOF system. So that's the difference between SDF and MDOF. We have already discussed on this. Now, this the analysis of the SDOF system is based on a model which is known as shear building model. So what the shear building model is that? That is, if I am having a structure like this, okay, I am having a structure like this, and there is a beam is there, column is there, etc. Then I am applying a load. When I am applying a load, horizontal load like this, then this columns, there will be only movement in the beams. That is, for example, it will be only moving like this. There will be no deformation in the columns. That is, it will be similar to a cantilever. That's what is a cantilever. It is supported at one end. Then how it will be deflecting? It will be deflecting like this. Similar to that only, the structure will be deflecting. That is, the whole mass of the structure is assumed to be concentrated in this horizontal level. That is the beam level. So that is the meaning of a shear building model. And as in the text, in one textbook, you can see here it is what is shear building model. That is a concept of a shear. A shear building is defined as a structure in which no rotation of the horizontal members at the floor level. Since all the horizontal members are restrained, again there is no rotation, and also there is no rotation of the horizontal member. That is, when we are applying a load, here you can see when I am applying a load like this, there will be no rotation. The horizontal member, there will be no rotation. It will be only having a movement or a deflection to the side. Then that is the meaning of a shear building model. Then these are some of the assumptions. That is, the total mass of the structure is concentrated at the floor level instead of distributed mass. Then horizontal members on the floors are indefinitely rigid as compared to the columns. That is, horizontal members are rigid compared to the columns. Deformation of the structure is not affected by the axial force in the column. That is the next important point. Stiffness due to columns and inertia stiffness is due to columns and inertia is due to slabs are considered. Okay. And no joint rotations in the structure. The load act horizontally so that the slabs move parallel to each other. So these are some of the assumptions of a shear building model. So the main thing is you need to understand is that is a structure which the analysis of a multi-degree of freedom system, we will consider shear building frames. Okay, the properties of the shear building frames are listed here. Okay, that is, one is the each of the properties you can just read, so it will give you an idea what is one frame. So that is basically an assumption. Okay, so here you can see this is a structure. This structure can be converted into a, this is the mechanical model, that is two masses are there, K1 K2 is there. So this will be our structure. The mass 1 is moving at x1, mass 1 is moving to x2. So that is the main thing you need to understand there. And so this is the mathematical model which we will be studying. Now let us take into consideration the here you can see I am taking a undamped system, that is here there is no, here you can see there is no this is a only spring is, this K is given, that is what is damped. Damped means there will be a stiffness will be also there, as well as a dashpot model will be, that is this will be K and C. This is in the case of a damped condition. Now we will be mainly focusing on the undamped one. Okay, and here you can see first of all I have to need to generate the equation. So in order to generate the equation, I need to first of all draw the free body diagram. For M1 there is one stiffness K, here you can see there is K is there. So I will be releasing this force, it will be K1 into x1. Now here it is K2 is there, so it will be pulling to this side, that will be K2 into x2 minus x1, because I am considering that x2 is greater than x1. Then again one more force will be also there. What is that? It is moving towards right. Therefore, according to our Newton's second law, according to the D'Alembert's principle, there will be another motion, that will be m1 x1 double dot. That is mass times acceleration. So similarly, I can draw this figures. Okay. So this is a free body diagram of m1. This is a free body diagram of m2. Now I am just equating the forces. So if I am equating the forces, I will be getting like this m1 x1 double dot plus. So I will be getting two equations like this. So I am just these things which we discussed in the class only. So that is the reason why I am just moving like this. So here you can see first equation is m1 x1 t. M1 or x the t you need not write it, because x1 is also a function. X1 is x is also a function of t only. Then k1 plus k2, like that I am getting equations. This equation can be converted into a matrix form. You can see here this equation can be converted into a matrix form, that is mx double dot plus kx is equal to 0, where m is this matrix m1 0 0 0 m2, k is k1 plus k2 minus k2 minus k2 k2. And if there is c is also there, if damping was there, it will be like this c1 plus c2 minus c2 minus c2 c2. Okay, that will be the only change that will be happening. Now, so here you can see so the changes. This is in the case of a that is a damped condition. There are three masses are there, m1 m2 m3. So I can generate the equation like this m1 0 0 0 m2 0. Same, this is the thing which I have discussed. So here we will be having the c term will be also there. Okay, so this is how we will generate the equation. So what is the general difference between this and SDF system? In SDF system, our equation in our motion was equation of motion was mx double dot plus cx dot plus kx is equal to 0. But here in MDOF, multi-degree of freedom system, m will be a matrix, c will be a matrix, and k will be a matrix. That is shown here. M, c, and k. And how it is forming is also shown here. So this is a way which we can equation. So the basic thing is that only about one thing you need to understand is that we need to draw the free body diagram. Then we can just simply write these equations. Okay. Now the next thing is lambda mass and constant mass. Lambda mass means a mass is distributed throughout an actual structure, but it can be idealized as a lambda mass or a constant mass. That means if I am having a structure like this, beam is there, column is there, so I am assuming that the total mass is located at a single point. So such an assumption as such a load is known as lumped or concentrated load. So we will be mainly for the ease of the analysis, we will be taking lumped condition. So if the mass of the structure is assumed to be constant at a discrete non-points, it is known as a lumped mass system. And a lumped mass at a node is determined from the portion. So that is, and if the entire mass is concerned, the opposite it is consistent mass. That is a real structure. So in our analysis for the EC, we will be doing like so. Here you can see M1, M2, M3. That is lumped mass. So here the first floor mass is, we are assuming it is located at the center. Likewise M1, M2, M3, M4, M5, like it is, that is lumped mass. Now let us look into the free vibration analysis. Okay, now we are going to find out the free vibration analysis. We can done by using these methods. One is solution of characteristic equation, Rayleigh's method, and Stolada method. So we will be studying on this. First one will be solution of characteristic equation. So for that, for easiness, I will be following this textbook. So here you can see this is our equation. Okay, this is the equation. For this is a 2 degree of freedom only. So M0, M1, this I will be getting. This matrix is known as mass matrix. Next one it is stiffness matrix. Now here you can see mx double dot plus kx dot is equal to 0. This equation, it is known as equation of motion. Now I have to solve this equation of motion. So how to solve this? Here you can see I am taking, here I am having x1 and x2. I need to find out x1 and x2. I am taking x1 is equal to capital X1 cos omega nt and x2 is equal to capital X2 cos omega, where cos omega nt is the, it will be the natural frequency. So I am substituting these things in this equation. That is, I can find out what is x double dot. X double dot will be the double integral of x1. So similarly, I will be getting, and I can rearrange this in this way. That is a matrix K matrix minus omega n square into m1 0 0 0 m2, and these terms omega nt and x1 x2 I am taken it as common. Now in this equation we know that the omega nt term cannot be 0. Okay, it is written here. That is omega nt term, it cannot be equal to 0. But this equation, it can be 0. So this equation is known as K matrix. K is this matrix K1 minus omega n square into m is equal to 0. So this equation is known as characteristic equation of frequency equation. Now here, what is our aim? My aim is to find out the omega n value, natural frequency. So if it is a 2 degree of freedom system, there will be 2 natural frequencies. If it is a 3 degree of freedom system, it will be 3 degree. So we need to find out each of this natural frequencies. Now you can see, so if this matrix is equal to 0, I can say that the determinant can be 0. So you can see here, I am converting this into, I am taking it is k1 plus k2 minus m1 omega square minus k2 minus k2 minus m2 omega n square is equal to 0. Now here you can see I am taking the omega n terms. So I will be getting an equation like this, m1 m2. So the same equation I think you can see here, that is this one I will discuss what is written here. So here you can see I will be getting an equation like this. Okay, m1 into, instead of here omega n I am taking, this is omega n. So here you can just see, this is, I can write how this a omega n raised to 4 minus b or plus b omega n square plus c is equal to 0. Now I need to find omega. So instead of this omega, I am just substituting here. You can see I am just substituting that is omega n square is equal to r. Now you can see x square plus bx plus c is equal to 0. From this I can find out what is r. Then what will be omega? Omega will be root of r. So I can find out both the frequencies. So that is known as it. So that values is known as natural frequency, and they are also known as Eigen values or characteristics values or normal values. There is a different names are there, you need to understand. That is normal frequency, natural frequency, or Eigen values, or characteristic values, or normal values. So this is a way in which I can find out omega, that is a natural frequencies. Now another term that is coming into consideration is mode shape. So what is mode shape? That is I am going to discuss. That is, the term mode shape or natural vibration shape are used in structural dynamics. It describes the deformation that the component would show when vibrating at the natural frequency. So the vibrational modes of a structure are the shapes that a structure will vibrate when it is excited. So you can see here I am showing different shapes. So here this one is having M1, M2, M3, M4. Also, what is the degree of freedom? Here it will be 4. Therefore, it will be having 4 frequencies, that is omega 1, omega 2, omega 3 and 4 natural frequencies will be there. So when omega 1 is happening, at a time only one frequency will be there. When omega 1 is happening, it will be vibrating like this. The shape can be different. When omega 2 is happening, when the frequency become omega 2. This is when frequency become omega 3 and this is omega 4. Here you can see the vibration is changing. So that how the structure will vibrate, that shape is known as mode shape. Okay, that pattern. So the mode shape is the deflected pattern related to a particular natural frequency and represents the relative displacement of all parts of the structure to that particular mode. Here you can see, that is when omega is equal to omega 1, this first floor will be moving this much. At the same time, second floor will be moving this much. Likewise, it will be. So here you can see it is only moving in one direction. But when here you look, when omega is equal to omega 2, the first floor will be moving to the right. This is also to the left. This is the same position. Again, this is moving to the left. Now here you look, one is to the right, other to the left. So it all depends. That we will be finding out. It need not be every time the same as that I have written. It is just a representation only. So now we will be finding out the shape, how much it will be moving. So that is meant by mode shape. Okay, that is the meaning of mode shape. The natural frequency of structures are the frequency at which the structure naturally tends to vibrate if it is subjected to disturbance. Deformed shape of a structure at a specific natural frequency is termed as its normal mode of vibration. Okay, so that is meant by mode shape. Here you can see this is another example. When it is one way, it is one floor is moving to the right, other to the left, like that it would be there. Okay, so we will be finding out how to draw this mode shape and all. Now here, if 2 degree of freedom, sometimes it will be like this. Another sometimes it may be like this. One will be moving to the right, other to the left, like this. It can happen. So it will be varying. Okay. Now let us find out with the help of a problem how we can do a problem that will be easier for you to understand. So I am taking just a small problem here. So here you look. Determine the natural frequency and mode shape of a structure shown in this figure. So what all things are given here? Mass is given, M1, M2 is given, then here 3 meter and 2.5 meter, then here it is given I value and E value is given. So many values are given. Okay. Now we will be going to find out how to, first of all I can draw the figure. So here it is a same figure. I am taking K1, K2. Now I need to find out K1 and K2. So it is a fixed point. So what is the equation of K1? K is equal to 12 EI by LQ. Now here you can see, here I is 2I. So I need to substitute 2 times I. So similarly I can find out K1 and K2. So I find out K1 and K2. Now I can write either you can just directly write this equation, but in some problems some changes will be there that I will discuss after this problem. Now I am just writing, this is my mass matrix, x1, x2 plus k1, k2 minus k2, x1, it is equal to 0. Now from this is a characteristic equation, k minus omega n square into m is equal to 0. This is our characteristic equation. These equations you need to know the equations. Okay, that is, so here you can see this is my question. So I am having a structure, this is my question. Okay, that this question I have converted into a mathematical model. So here this is my characteristic equation. So you can directly write that also, k matrix minus omega n square into M matrix, this determinant is equal to 0. So I know what is K. K is equal to K1, K2, K3. That's K1 plus K2 minus K2 minus, I can write like M is equal to M1 0, M2 0. Now you can see here I am having all the values, right? By expanding I will be getting this equation. That is, instead of expanding here you can substitute the values also. Now we know what is K1, K2, etc. So while after substitution and all, you will be getting this equation, because we know all the factors, that is 897,600 omega n square minus 46.116 into 10 raised to 6 omega n whole square, omega raised to 4 omega plus 213.3 into 10 raised to 6 is equal to 0. Okay, now here you can see, now I can solve for omega, so I am taking omega n square is equal to s. So here a s square plus bs plus c is equal to 0. Okay, that is the same thing. Now this is the equation which I got. Now what is I need to find out what is s. S is equal to minus b plus or minus root of b square minus 4ac by 2a. So I can just substitute, I can find out. So I will be getting s, there will be two equations, s1 and s2. So s1 I am getting it as what is the value? S1 is equal to 5.139. 5.139. S2 is equal to 46.24. So it is written. Now what will omega? Omega will be 2 times. Omega 1 is equal to root of s1. Similarly, omega 2 is equal to root of s2. So I am getting omega 1 and omega 2. So my frequencies are, here you can see, omega is equal to 2. So omega 1 is equal to 2.27 radians per second. Omega 2 is equal to 6.8 radians per second. Okay, I found out these two. Now, so these are my natural frequencies. I got the natural frequencies. That is my first aim. Okay, so till I think it is okay for you. That is, I'm just expanding. That is, here you can see omega 1 and omega 2 I go. Now I need to find the mode shape. Now you can see here, mode shape means I need to find out x1 and x2. Okay, now this is my matrix, that is K1. Here you can see K1 into K2. This matrix is into x1 x2 is equal to 0. This is my first one. Here first I am substituting omega 1. Okay, what is this x1 and x2? X1 and x2 means, so x1 and x2 means I am having a structure like this. Two bays are there, m1. So x1 and x2. First I am with the first one with omega 1. It will be deflecting sometimes like this. It will be deflecting like this. I can draw the deflection in a single line. Okay, so this one may be the first floor, how much it will be moving, that is x1. Next is x2. Then in omega 2 also similarly I will be getting another shape, that is first one and second one. First one will be x1 and x2. Now I need to find out what is x1 and x2. So I can draw this figure. So for fourth one, for this I am first substituting, that is where you can see I am substituting omega 1. It is written here, substituting the value of mode shape omega 1. So here you can see, so this is my equation, that is we started like this only, that is K1 plus K2 minus M1 omega square minus K2 into K2 minus M2 omega 2 square. This into x1 x2 is equal to 0. So how did I got that equation? That is, here you can look. Here you can see this equation. If I am taking, here I am having this determinant. Okay, before that I have got an equation like this. That is, here, that is, I have substituted x1 is equal to x1 cos omega nt like that. Then I have got an equation, that is cos omega t term is equal to 0. Cannot be 0. That is, we started from here. That is is here. Here you can see. Yes. Now this is it. So here you look. K1 plus K2 omega n into x1 x2 cos omega. So here this term cannot be 0. So I am taking, but the other term, this whole term can be 0. I am taking this term as 0. Then only I will be able to find out what is x1 and x2. Okay, so that is the reason why I am writing this equation like this. So I am writing the equation. Okay. Okay, there is here there is a small change here. Some mistake is there. There is here instead of omega 1, you have to take 2.27 radians per second. So I am just substituting here instead of omega 1, I can k1, k2, omega, everything I know. I will be getting an equation like this. 23321 x1 minus 19.2 into the x2 is equal to 0. So here I can write x2 by x1 is equal to 1.215. That is what is the meaning of this? So I got a value that is x2 by x1 is equal to, by substitution and all, I am getting 1.215. That is x2 is equal to 1.215 x1. Now I am just substituting x1 is equal to 1. So when x1 is equal to 1, what will be x2? 1.215. So here you can see how the mode shape is drawn. Here you can see, look, now it is drawn horizontally, but you can draw like this. That is when x1 is equal to 1, it's 1. What is x2? x2 is equal to this. So this is 1 and this is 1.215. What is the meaning of that? When the natural frequency is equal to omega 1, this will be my mode shape. Now similarly, when it is mode shape, when omega n is equal to omega 2, here I am substituting omega 2, then you can see here I am getting x1 by x2 by x1 is equal to negative sign, minus 1.697. That is, again, when x1 is equal to 1, what is x2? I am just putting x1 is equal to x2 is minus 1.69. So how will be my mode shape? If I am draw, then the second mode shape will be, when it is 1, it will be minus. So it will be to the opposite side. So this one will be 1 and this one will be 1. So with the second natural frequency, the first floor will be moving towards the left, second floor will be moving towards, first floor will be moving towards the right and second floor will be moving towards the left. So likewise, I can easily find out the mode shape. So these are the things you need to understand here. Okay. And similarly, there are a lot of problems are also here. You can see here, determine the natural frequency system shown. The same problems only 2m and with the one which I have discussed is based on what was based on that is m1 m2 was given. Instead of m1, you can give a constant can be given. So likewise also the questions can be asked. Okay. And another question is also there, that will be this question. This is an important question. Here you just look. That is, here this is says 2 degree of freedom only, but I am having 3 k values are there. K, this is, but they are all equal. And sometimes these k values can be different. It can be k1, k2, k3. So that is, I will just draw that figure. That is I am having a that is a structure like this, m1, then again and m2, then again there is a system. This is k1, k2, k3. Okay, now what is the change? That is normally how you are writing k matrix, k1 plus k2 minus k2 minus k2 k2. This is the way I am writing. But here I write like that? Here there is only 2 movements are there, but can I write that? No. So for that I need to draw the free body diagram. So here let I am drawing the free body diagram. Here m1. Here towards this I am having k1 x1. Here I am having mx1 double dot. Towards here I am having k2 into x2 minus x1. Then what about the second figure? Here I am having again k2 into x2 minus x1. Then what are the other things? Towards this side I am having k3 into x2 and towards the opposite side I am having here. Here I am having, what will be that, this is m1, this is m2 into x2 double dot. So my equation, there will be some changes. K3 term will also be coming. Okay, so that is a thing you need to understand. So finally when I am writing the equation, that is, here you can see I am writing this equation. There is k term is also there, so there will be some small change will be there. So here 2k1, 2k2, like that, some small changes may be there. So I will just do this. I am writing this equation, m1 x1 double dot plus k1 x1 minus k2 into x2 minus x1 is equal to 0. Next one, it is m2 x2 double dot plus k2 into x2 minus x1 minus k3 into x2 is equal to 0. Now I am just from here I am just other terms I am taking, m1 x1 double dot plus k1 x1 plus k2 x1 minus k2 x2 is equal to 0. Here also m2 x2 double dot plus I am having what all values here in k2, that is minus k2 x2, k2 x1, here you can see minus k2 x2 plus k2, here also one k3 is there, k3 into x2 is equal to 1. So how I can write the matrix from here? I will be getting a matrix that is m1 0 0 m2 x1 double dot x2 double dot plus, what is my k matrix? Here there is k1, so k1, then what is the other term which is there, plus k2 minus k2 minus k2, here it is k2 plus k3 into x1 x2 is equal to 0. So what is the change that has come here? Here k3 term is also there. So if a question, even if it is a MDOF system, 2 MDOF system, this you need to understand how to write this equation. Then only this k matrix need not be always like this. There can be some small changes can also be. So that's the reason why I have just explained that. Okay. Some problems I have written here. Different methods are to follow. Some 2 or 3 problems are discussed here. Same only, but you can just follow what I have studied here. That is, find the mode shape and of a m1 and m2 are given. Then how to find out. Okay, this is another method only, but you can follow the method which I used also. It will be easier for you. Okay, so just go through this video and just understand how we are arriving at this. So the basic things which you need to understand is that we have studied about how to find out the omega 1 and omega 2, and also how to find out the mode shape. Okay, different textbooks having different ways the mode shape can be found out. One method, easier method is which I have followed, so you can follow that. Okay, so that's all for this class. Thank you.